All right. Friday afternoon tutorial. I will do whatever you guys want to talk about. What do we want to talk about? Problems on the homework? Biggest problem? We're on, did I post the video? I don't think I did post the video. Did I do it? I know I did a double slit lecture from a tutorial, but did I, in that lecture, did it also include thin films? I didn't post I didn't post a tutorial for Palm Set 9 materials. So I guess we can go over that. Yeah. Literally, if you're good enough, you could go through that Google Drive and find it. The yeah, let's do it. Excellent choice. So those of you paying attention at home, before I turn the camera on, I gave everybody in the room the answers to test week, next week's test 3, and then swore them to secrecy. So, yeah, I don't know. What? Assign a sheet? Actually, you know what? Great idea. Take out a sheet of paper, Adrian, put your name and ID on it and pass it around. Just so I know. Because if you're willing to show up on Friday afternoon,
When you don't have class.
Yeah, I don't have class.
you know, and when, especially, yeah. Okay. I'm sorry, would you like a cookie? Oh wait, I don't have cookies. So, now all of these are thin films. One, thickness of a soap film that would appear black if illuminated with 480 nanometer light. So lambda is 480. N of the soap is 1.33. So we have light hitting, doing this, 1.33. If it bounces off a higher, God, my handwriting's horrible. Bounces off a higher, there is a phase shift. 1 to 1.33 is higher, you get a phase shift. 1.33 to 1, because it's a soap bubble, air, soap, air, there is no phase change. So we've got an odd destructive situation. And let me get the cheat sheet back out. Soap. Okay. So we have an odd destructive. So odd destructive is M lambda. So 2T is equal to M lambda. Now that lambda, the lambda is 480 in air, but since we have to take into consideration the index of refraction of the middle, we put the N in there. We're looking for next, give the next two thicknesses of the bubble that would appear black in the same light. So thickness is M lambda over 2N, where M is equal to 1, 2, and that's it. 2, what is the minimum air layer between two sheets of glass if the light at 450 nanometers appears bright? So glass, air, glass. Really, the glass doesn't matter. We can use water, whatever. The index of refraction is going to be higher. So this 1.33 to 1 is lower. 1.0 to 1.33 is higher. This is an odd constructive. So odd constructive is 2t m plus 1/2 lambda. The 450 is lambda. The middle substance is air. Index of refraction is 1. So it looks like this. 2.
Oh, okay. So number 4 was the first one.
What?
This number 4 on paper, and this is number 5. That's why I was confused.
This is the problem set that I'm reading.
Yes, but your number 1 is our number 4, and that's why I was confused.
What do you mean you're number 4?
One on black.
Isn't this the one on Blackboard?
The order
Hold
of
on.
the questions are different. That's why I was like, yours is
Okay. All right, I'll use this.
That's why I was like,
All right. Let me. I'll double check. Four. Okay, that's 5. Minimum air layer means m has to be 0. If you got m plus 1/2, the minimum m value will be 0. If you just have m, the minimum value of m is 1.
Dr. Ishler, what do you want us to do with your sign-in sheet?
Oh, give it to me. No, destroy it, because I'm not going to count it. All right, thank you. All right, now we'll do one. Soap bubble has index of refraction of 1.33, minimum thickness. So soap is an odd, this is odd destructive, this is odd constructive. So for 1, really the lather, rinse, repeat, T equals lambda over 2, m plus 1/2. Do that. Two is a little bit, I should throw, well, I'm not going to throw out 2, I just say I won't grade it. 2, it says, light of wavelength blah is through a soap film. What is the minimum thickness of film that will give an interference when the light is normally on it? Question, are we talking destructive or constructive? If it's, let's say, destructive, that's odd. So 2t over m lambda over n, solve for t. M is equal to 1. All right, number 6 is the one that I really want to cover. All right, number 3, 1 through 5 are just lather, rinse, repeat. Minimum thickness of a non-reflecting film coating on a glass lens. So this is 1.0, the film is 1.3, the glass is 1.5. Low to high, phase change, low to high, phase change. We get an even. So we're talking about non-reflecting film. So a non-reflecting film means you've got destructive interference. So we're talking about an even destructive. So 2t for an even destructive m plus 1/2 times lambda over n. Huh? I know that it's even because there are two increasing indexes of refraction interfaces. I know it's destructive because it's non-reflecting. Non-reflecting means you don't see it. Hence, that value. So t is lambda over 2n m plus 1/2. It's an even destructive. Even because they're two dark dots. Destructive because I say non-reflecting. How do I know that 1 and 2 are what they are? In 1, it says maximum reflectance. So it's bright or constructive. Non-reflecting implies dark or destructive. All right. Number 6 is the one that I want. Because number 6 I like. Which means, oh no, it could be 6 on the test. A thin oil slick floats on water. Huh? Okay. You have air, 1.0. You have oil, 1.5. And you have water, 1.33. Low to high, phase change. High to low, no phase change. We're dealing with an odd change. Only light of wavelengths 650 nanometers and 390 nanometers appears bright. So 650 nanometers and 390 nanometers. All right. These both appear bright. So we're dealing with an odd bright situation. Odd bright or odd constructive is 2t equals m plus 1/2 lambda. Huh? Well, there's no. This is where, because see, if you pick m equals 0, you get the thickness for one specific lambda. But this thickness has to match both. Well, actually, t doesn't need a subscript. So 2t equals m1 plus 1/2 lambda 1, and 2t is equal to m2 plus 1/2 lambda 2. No. Thank you for playing, but no. You set them equal to each other. Because the thicknesses are identical. Because we're looking for the thickness where both of them are constructed. Now what we're going to do is divide both sides by lambda 1. And then multiply by 2. Oh no. I'm going to subtract by 1/2. And I get this. Now, lambda 2 is 390, lambda 1 is 650. You could invert them, it doesn't really matter. But lambda 2 and M2 are associated together. Lambda 1 and M1 are associated together. So L2 is 390. L1 is 650. And we get this. It's going to be, well, M is going to give you an integer. What you need to do is you do what you love to do. You're going to plug in M2 into this equation, and you're going to solve for M1. If you get an M1 value that is not an integer, you throw it out. The first time you get an integer, that's the guy you want. So, when I initially did this, I had like, I would end up with M2s of like 35, which means you'd have to sit there and compute it 35 times. No, I'm not doing that. On the test, at worst, it will be like 4 or 5 times. So let's see how mean I was on this problem. If M2 is 0, it's 390 times 1/2, or 390 over 65 times 1/2, minus 0.5, and I end up with negative 0.2. So that's not an answer. So now I put in 1. And I get 0.4. M2 is 2. And actually, if I see the pattern, I can kind of figure out what it's going to be. Oh, now it is. Okay. And I get an M1 of 1. So M2 is equal to 2, and M1 is equal to 1. So 2t, or t, is equal to lambda 1 over 2, M1 plus 1/2. Lambda 1 is 650. The M1 associated with 650, which is lambda 1, is M1, so it is 1 plus 1/2. Whoa, whoa, whoa. Hold on. All right, ask, since that's up on the board, what's the question? Because it says minimum thickness. So when it says minimum thickness, you're looking for the first time you get anything proposed. Once you get those integers, you stop what you're doing and get thickness. And this problem I love because I think it's a little bit more involved than the simple silk bubble case. I think I did it in lecture. There is a, I'll put that up because just as there's an optics packet, I made a thin film packet. So I'll find it and then put it up.
So it has to be greater, it has to be one greater. If the M2 has one.
All right. You said M2 as 1, which is nonsensical.
If M2 is equal to
M2 is equal
1.
to 1. Oh, did I put in? M1 is equal to 1. What I did is I defined lambda 1 and said lambda 1 is 650. Then I said lambda 2 is 390, which means the 650 has a lambda or an M1 associated with it, and a lambda 2 has an M2 associated with it. Now, possible solutions are 0, 1, 2, and 7. So what I had to do is I set up a chart where I plug in M2s and see what M1 comes out. The first occasion where M2 and M1 are both integers, I'm solving. Yeah, I can solve for M1 and then, yeah, work the other way. Oh God, maximum things? No. That's, no.
So they both have
It's not even a problem that I'm
So
thinking about.
this wouldn't be because M1 is zero. This one couldn't be it because M1 is
It's a
zero.
fraction. M's other than integers, or values other than integers, are not allowed.
Is 0 an integer?
Yeah.
Okay. I don't-
Zero, I will say this, okay. Look, if we don't say integers, just say 0, 1, 2, etc. I don't know, is it integers?
Integers are like whole numbers, but it's
Do you put
it's
zero?
plus or negative.
Is it natural numbers? 0, 1, 2, and then integers?
I mean,
1 to
counting
0?
them.
Like there's a set of numbers where it's 1 through infinity, 7 by 1. And there's another set where it's 0 to infinity. Once again, this is physics, not math. I don't care. All I know is that if it's an m plus 1/2, the possible solutions are 0, 1, 2, etc. If it's m, then it has to be 1, 2, 3, etc. The moment I found out that I had integers of m2 equals 2 and m1 equals 1, I solved for thickness using any of the thickness equations. Lambda 1, m1, I could use lambda 2, m2, you would get the same answer.
So it'd be a case of one.
Yeah. So it's a lot like the I was doing it earlier today. The Doppler shift problem, where I give you the frequency away and towards, and then I go, well, what's the velocity, and then what's the frequency of the moving object? The first thing you do is solve for velocity. In this case, we're solving for our m. And then you go back and pick, like in the Doppler shift, you can pick towards or away equation. It doesn't matter which one. You're going to get the same answer. Thank you.
And so we don't have to put in years for these.
No, I put like nanometers. Probably the in that experiment last night, they're dancing around something where it's critical that you need to know it. The way that I have things set up, the way that I do it, you can use degrees or radians. Yeah, they're different. 2 pi radius. Yeah, I understand like there was the one where it was like from the second dark band up to the first dark band below, what's that angle? You can use degrees of radius, unless I specify. Yeah, only in lab. It's not a big deal. 360 degrees is too high. It's an inversion. Dude, there's one thing where if you there's some things where I'm thinking about it more, I think about it more in a test situation. You can use degrees or I would tend to use the way that I'm using this test is I don't know. There was, let me tell you, it's a quick story. Years ago, we used to have practical in last year we did. The first thing we did when I was a professor, we started our freshman year, we voted unanimously to get rid of the flashlight. We thought it was unacceptable. But when I was a TA, when I ran the practicals, I want people to maximize their score. So if they got caught on something heavy, but it prevents them from getting the majority of the points, I would say, I'll give you a hint for, depending on the severity, 2.5%. And back then, the way that we did it, we didn't have to have the option. And there was a student who had his calculator degrees and he did not understand why the equation was blowing up. So about halfway, it's only 1 hour to the left of the practical portion, there's an hour test. After half an hour, I go, I'll give you the answer for a point. Now the dude had a 97 average in the lab. He was going to get an A. This was all about personal pride. He goes, no. I'm not going to give you a point. I said, fine. 15 minutes later, now they're down to 15. I go, I'll tell you for 2 minutes. And he goes, no, I'm not going to do it. And I come back now, 10 minutes later, so now we're down to 5 minutes. He would have been done a half hour early had he just done it. And I go, all right, now it's going to cost me 5 minutes. What do you want to do? Do you want to get 50 on this thing, or do you want to get 105? And he goes, okay, it's fine. And I wrote on a little slip of paper, R-A-D, not M-E-G. Slid it across. It walked away. I got about 2 tables away before I heard, bleep, 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 you bleep, bleep, bleep. And I went, yeah. He was furious. But now the poor guy only got a 96.8 in lab rather than a 97. Boo-hoo. Done back. So.
Yeah, same.
Huh?
Yeah, I wish that was my case.
Same as, now we're back into a little break. Test 3 is going to be same, 25 multiple choice, appetizing, 3 problems. Huh? I have no idea. Oh, it's what, 1? All right, let's.
Wait, what's the units for A? Are there no?
Correct.
One of the problems of metaphysical certainty is a mirror or lens where you're going to have to get I, M, and define its qualities and give me a two-ray diagram, not three. The first ray always through the middle. Second ray always starts parallel and either gets bent towards the focal point or away. Third ray, that third ray ends up parallel. Now, how it ends up parallel depends on the situation.
So, is it always from the top of the image to the middle, or from the top of the image to the
Top of the object through the middle of the... Like if you just had this and it's a lens, it passes through like that. If it's this and a mirror, it does that. I would say that one of the others is going to be a single double slit. Count the bands, count the angles, stuff like that. The other stuff, I mean, we've covered thin films. I mean, diffraction gratings, they were good problems, but single double slit is better than diffraction grating. You may need to know the differences between single and double slit and diffraction grating for multiple choice. Single slit, min only. Double slit, min and max. Diffraction grating, max only. Let me take a look at the problem sets. Oh no, I got them. For the multiple choice, I would say there's going to be a few in the rapid fire problems. Problem 8 of problem set 7. Yeah. Or I'd have to make it really complex to make it even an appetizer, but polarization could be a good topic. So thin films, polarization. I mean, I could go with more lenses, but that's just overkill. Oh, Snell's law, not Snet's law, whatever that was. Snell's law, refraction. I don't know which one we're talking about. So a year ago, I said this would be a good problem. Which problem are we talking? Which problem set? Yeah, that's a polarization type problem. I think probably as a good appetizer, it would be you've got like 2 watts per meter squared coming out of this thing. If the angle between the two is 40 degrees, what's the initial intensity? So all you do is I1 is equal to I naught over 2. I2, because this is unpolarized light. I2 is I1 cosine squared theta. So I2 is equal to I naught over 2 cosine squared theta, or 2I2 cosine squared theta is equal to I naught. And then you just solve it. That's not a problem, that's an appetite.
Okay, so are you saying 2 watts per meter squared and that's what's coming out of
Yes.
the
So your I2 would be 2. Your theta would be 40.
So that is your I2?
Yeah. Because it's 2 over here. So I naught, I1.
So it'd be 2 times I2 cosine squared or
Oh, how do I do? Well, what I would do is I'd just go cosine 40. Yeah. Or do it like that. That's effectively what that is. Okay. All right. Any other questions? Sure, we can. What we'll do. What we'll do is I want to do maybe what? Yeah. Indexes of refraction or ratios or radians. But that's, go ahead. Oh, if like, yeah, I think I know. So the angle between these two is 40 degrees. what is the ratio of the light coming out of this thing over its initial intensity? I1 is I0 over 2. I2 is I1 cosine squared theta. So I2 is I0 over 2 cosine squared theta. So I2 over I0 is cosine squared theta over 2. So if I say, given these two filters with an angle of theta, what's the ratio of the exiting light over the initial light? And it would be this. Cosine squared theta spits out a number. Dividing a number by a number gives you a unitless number. And there you go. If I ask for theta, then you just extract it, and then you get an answer in degrees. And what I think we should do is do a multiple choice, and then I'll be fine if we end at that point. This is spring of 2015 alpha version, test 3. Light reflects off a substance that has a lower index of refraction than its current medium. Which of the following is true? What does the phase do? If it reflects off an index of refraction that's lower, there is no phase change. In a vacuum, the light's wavelength is 500 nanometers. It passes into glass. The index of refraction is 2. What is its new wavelength? Well, what we've learned is that lambda prime is equal to lambda over n. So the answer is B. The equation for index of reflection, or I'm sorry, that should be refraction, is C over V. The lowest value that the index of refraction can ever have is 1. Spectroscope uses what? We won't have this on the test, but it's a diffraction gradient. Is 1. Because nothing can go faster than the speed of light, and so C over C is 1. The image is to the right of the lens. The object is to the left of the lens. The image distance is what? Should be greater than 0. The image is to the right of the lens, therefore the image distance is positive. Convex lenses are also known as converging. Light in water travels slower than light in a vacuum. Snell's law is what?
Light travels fastest in the vacuum.
Hmm?
So the N1 is cosine 1 equals N2 cosine.
Should it be N1 sine theta 1? Sine. All right, 9 is just testing your knowledge. You have monochromatic light. That's light of one frequency. Mono, one, or mono, and then chromatic, light, one light. Which equation represents small angle approximation? A. Your single slit experiment is now underwater. How is its new diffraction patterns different from its pattern when the experiment was in air? Let's talk about this. The single slit experiment is d sine theta equals m lambda. Now, really, when you introduce the medium being water, the lambda becomes lambda divided by n. So the wavelength of the light changes. Vacuum, n is 1. When you put it in water, n gets bigger. Since it's in the denominator, the sign of theta gets smaller. So the theta, you can go to an extreme. As n becomes infinite, sine of theta becomes 0, which means that theta becomes 0. So the theta decreases. If the theta decreases, the bands get closer together. Think about how sine changes as n increases. N increases, the denominator increases, the ratio decreases, sine of theta decreases, so theta must decrease. Convert 2 meters into angstroms. 1 angstrom is 1 times 10 to the 10th. Polarized light passes through 2 polarizing filters. The filters are 90 degrees different from each other in terms of their axis. What is the final intensity? No light. What is the intensity of polarized light after it passes through 1 polarizing filter? It gets cut in half. Light in a vacuum reflects off glass. The light experiences a phase shift of lambda over 2, or 180.
Hey, Dr. Rushmore,
Yeah.
on that number 14, I said it was polarized light. I thought it has to be depolarized for it to get cut in half after the first one.
It doesn't matter if it's polarized or unpolarized. As long as those filters are 90 degrees separate, there's nothing coming out of that back end. Two meters into nanometers is that. The region of a bubble appearing black represents what effect? Destructive interference. The units of magnification are none. The image is behind the mirror. The image distance is, it's always less than 0. If the image is behind a mirror, it has negative image distance. You see yourself in a mirror. Which effect is being demonstrated? Reflection. The smallest value of index of refraction is 1, yes. 2 rays of light are compared, yeah. The one that has the higher frequency has the smaller wavelength. Light passes from water to glass. Which of the following is true? Or I'm sorry, which of the following is false?
Water is 1.33 glasses.
Oh. The false statement is B. The frequency never changes. Therefore, that's the false one.
Isn't that the one that you said like 5 times?
Yes. And I can guarantee you that people are going to miss it. You have light that has a wavelength of 500 nanometers, but the light is 300 nanometers in a substance. Which of the following is true? And there is some bleed off on the page. It's not velocity is the same. It's C, the frequency of the light in both mediums are the same. This one's probably frequencies of the light are different. Index of refraction in the substance is something, but C is obviously the true statement. Your magnification is -2. Your image is what? Inverted and enlarged. Yes.
So, yeah, if it's negative, it's inverted. But what was the, it's greater than
If its
1?
magnitude is greater than 1, it's enlarged. Okay. I think we've done good work. All right. Next time I'll see you will be Tuesday. Later.